Welcome back, guys. So I have got this question from Mod 1 Olympiad number theory exercise 1.4.1, and I want you to pause the video right now and see if you can get to the answer. Try it, give it a shot, see if you can get to the answer. All right. So when we look at this question, what is the very first thing that comes to your mind? So this question wants us to prove that these three expressions, it wants us to find for what values of n these three expressions are prime. Okay, so the very first thing that comes to my mind, and probably yours, is that primes have a huge weakness. Prime numbers have a huge weakness, and that is almost all of them are odd except 2, and that is an even number. So if we prove that these expressions, since we have to prove that these are prime, okay, so if these expressions, if we force them to be even, then we know that there is only one even prime. That means 3n minus 4 has to equal to 2 or any other expression. Okay, so the very first thing, when you look at a question which tells you to prove that this expression or these expressions to be prime number, the very first thing that should come to your mind is that try parity, try smaller modular basis. Okay, so if, because that will restrict your cases to 2. Okay, so let's try our parity. Case 1 will be n is even. Let's see what happens if n is even. If n is even, n is equal to 2, okay, then that means that 3n minus 4 will be 3 2k minus 4. That means this will be 6k minus 4, and we know that this is an even number because it has a factor of 2 in it, and this is an even number, and even minus an even number is an even number, and we know that the only even prime number is 2. Therefore this expression 3n minus 4 is equal to 2, and from here we can get the value of n as n is equal to 2. So when n is equal to 2, this expression is a prime number, 3n minus 4. What about the other expression? What about 5n minus 3? Is it a prime? Let's see. 5 2s are 10. Okay, so 5 2s are 10 minus 3, that is 7. So yes, it is a prime number for the second expression. What about the third expression? 4n minus 5. Okay, so 4 2s are 8 and minus 5, that will give you 3. So yes, it works for the third expression as well. So when n is equal to 2, all of these three expressions are a prime number. Let's see what happens in case 2 when n is equal to an odd number. So our case 2, n is an odd number. Okay, so when n is odd, we try that 3n minus 4. When n is odd, we get 3 2k plus 1 minus 4, and you will get 6k plus 3 minus 4, and this will give you 6k minus 1. So this is an even number. Okay, this is an odd number, and even minus odd is an odd number. Okay, but there are so many odd prime numbers, which means this expression did give us something useful. We have to force this expression to be even. If you try the same thing with 4n minus 5, you will again get an odd number, and there are so many odd primes. If you try with 5n minus 3, okay, 5n minus 3, let's plug in 5 when n is equal to 2, when n is equal to 2k plus 1. Okay, when n is odd, what happens? Let's see. So 10k plus 5 minus 3, plus 5 minus 3 is equal to 2. Okay, so this is an even number. Okay, this is an even number as well. Therefore even plus an even number is an even number, and we know that there is only one even prime number, and there is 2. Therefore this expression 5n minus 3 is equal to 2. From here we can get the value of 2, which will be 5n is equal to 5. From here we get that n is equal to 1. Okay, so when n is equal to 1, this expression 5n minus 3 is a prime number. What about the other expressions? Are those prime? Let's see. So 3n minus 4, Let's plug in our value of n here, which will be 3 minus 4, which is minus 1. Is minus 1 a prime number? Not at all. All of prime numbers are strictly greater than 1. So we have solved all cases. We have solved for every single number, because either the numbers can be odd or even. So we have solved every single possibility, and we saw that when n is equal to odd, this case fails. When n is equal to even, there is only this possibility, that when n is equal to 2, then this expression will be a prime number. Okay, so the key here is, whenever you are given an Olympiad problem and that wants you to prove that if some expression is prime, then the very first thing that you do, the very first thing that should come to your mind is try parity. Okay, if parity doesn't work out, try modulo 3. That's the whole key. Comment down your thoughts below. Thank you so much.